Hello class, we're about to start section 2.4, set operations and Venn diagrams with three sets. Our objectives: perform set operations with three sets, use Venn diagrams with three sets, use Venn diagrams to prove equality of sets. Set operation with three sets. There is nothing new in this section. If you can add two numbers, you can add three, one step at a time. We know how to find the union and intersection of two sets. We know how to find the set's complement. We can now apply these same set operations to situations containing three sets. Set operations should be started with the operations inside of the parentheses. The other operations should be performed from left to right. Every element in the universal set can only be listed once on the entire Venn diagram. Example: let's continue our survey from 2.3. Recall, we asked women if they smoked cigarettes and denoted those who did with set A. We then asked if those women drank alcohol, which we denoted as set B. Now, let's introduce a third survey question and ask participants about their illicit drug use. Those who do use illicit drugs will be part of set C. Remember, the universal set for this particular problem will be all the women aged 18 to 49 that were interviewed. Now, we have our Venn diagram here. Now we have three overlapping circles in the diagram. Let's analyze what each of the 8 regions of the diagram represent. Okay, now let's start with region 5. Region 5. This region is in the center of the diagram and shows the overlap between all three regions. These would be the women who smoked, drank, and used illicit drugs. The set representation would be A intersect B intersect C. Okay, now we go to the second region. It says this region is the intersection of set A and B, but doesn't include C. These would be the women who smoke and drink, but do not use illicit drugs. The representation for this set is in parentheses A intersect B, which you would need to do first, intersect the complement of C. So if we look here, A intersect B would be 2 and 5. And then intersect the complement of C would just be 2. So that works. Now we go here to 4. This region is the intersection of set A and C, but doesn't include B. Let me scroll up just a little more, because I do have this figure down here. This region is the intersection of set A and C, but doesn't include B. These will be the women who smoke and use illicit drugs but do not drink. Now we look here at 4. This includes region A, region C. So now we have 4. Now the set representation would be A intersect C, which would give us this 4 and 5, but it's the intersection of B complement, so that would take out 5 and just leave us 4. Now, with 6, if we look at region 6, this region is the intersection of set B and C, but doesn't include A. So we look here at B and C, and this is 6, and it doesn't include A. Now, these would be the women who drink and use illicit drugs but do not smoke. The set representation would be B intersect C in parentheses. B intersect C will be 5 and 6 here, but it's intersection of A complement, so that would leave 5 out. So your region would be 6. Now we go here to region 1. This region is comprised of set A only. No other sets included. These will be the women who only smoke but do not drink or use illicit drugs. The set representation: A is the intersection of B complement intersect C complement. So that means basically we would do no B's, which would be A and C, intersect no C's, which will only leave us A here. So that is a set representation. Now, we come here. Actually, we already did region 2. So we go to region 3. This region is comprised of set B only. Region 3. No other sets included. These would be the women who only drink but do not smoke or use illicit drugs. So the set representation would be B intersect parenthesis A complement intersect C complement, which will leave us with 3. Now for 8, this region represents elements in a universal set that are not in sets A, B, or C. We see that 8 is on the outside of these circles here of A, B, and C. These would be all women who do not smoke, drink, or use illicit drugs. So the set representation would be the intersection of the complement of all of these 3 sections. Now there is one section that we did not cover, and we will cover that now. It's actually 7. Now, with 7, we see here that 7 only includes C. So this region is comprised. Okay, class, what I did here was I took the liberty of typing this out, and I will explain. The region that we didn't have here was 7. Now, if you look here at 7, it's just comprised of C. It's only C. So this region is comprised of set C only, no other sets included. These would be the women who only use illicit drugs but do not smoke or drink. The set representation would be C intersect parenthesis A complement intersect B complement. And that will be your final answer. Now, we scroll to the next page. It says here, using roster method in 3 sets. Now we do some examples using set operations in 3 sets when given the sets and roster method. Use the same set operators and order of operations as we did in 2.3. Now we have let U, or the universal set, is equal to, if you notice we have 1 through 7. Set A is 1, 3, 5, 7. Set B is 1, 2, 3. And set C is 2, 3, 4, 5, 6. Now we want to find C intersect the complement of A union B. Now, first find the complement of C. This is everything in the universal set, but not in C. C is equal to 1, 7. It says here, there's one thing missing here. It should be C complement is equal to 1, 7. Okay, now, hey class, I just realized something here. This is supposed to be C complement. So it's be C complement intersect A complement union B. So that's why we first find C complement. This is everything in a universal set, but not in C. So C complement is equal to 1, 7. Now find A complement. This is everything in a universal set, but not in A. If we look at A, we have 1, 3, 5, 7. So if you notice, that leaves us 2, 4, and 6. That's A complement. Now we find A complement union B. Now A complement is 2, 4, 6. Now we look here at B, which is 1, 2, 3. Now we will combine these, but anything that repeats, we only count once. So it'll be 1, 2, 2 repeats, we'll write it once, 3, 4, and 6. So this is A complement union B, which is 1, 2, 3, 4, 6. Now find, this is supposed to be C complement intersect A complement union B. Now we already have A complement union B, which is here, but we have it written here as well. We'll intersect what we got in step 3 with step 1. Now this is C complement, which is 1, 7, intersect, this is A complement union B, which is 1, 2, 3, 4, 6. Now the only thing they have in common is 1. So that is their intersection, just 1. So it'll be the set of 1. The final result is C complement intersect A complement union B is equal to the set of 1. Now, we go here. We have B union C complement intersect A. Now, let's assume that we're going to use all of these values as well. So first, let's go through this. First, we're going to look at B union C. So if we have B union C, let's write out all the values for B and C. So we have B union C will give us 1, 2, 3, 4, 5, and 6. Now we have to take the complement of this here. So we will have, this is B union C, and we would take its complement, the complement of the universal set, which would give us only 7. Now I changed this slightly, which you could change in your notes. Instead of writing 1, write B union C, and you could put that in parentheses. And this shows the set that we just talked about. So now, our next step will be this. Since we know B union C is 1, 2, 3, 4, 5, then that definitely let us know that B union C complement would have to just be 7. Because that's the only thing left in the universal set. So now we want to intersect that with A. So now we look back at A here. A is 1, 3, 5, 7. So our next step, we would do this. We would take A, we would take B union C complement, intersect A, and we will have it equal. Now we know B union C complement is 7, and we want to intersect that with A. A is 1, 3, 5, 7. Now if we look here, the only thing we have in common here is 7. So our final answer would be the set of 7. And that is our final answer. Now we have another example. We're given a universal set which is 1 through 9, A is 1 through 5, B is 1, 2, 3, 6, 8, and C is 2, 3, 4, 6, 7. Now they want us to find A union B intersect C. So the first thing we need to do here is this. We need to find B intersect C. Now we can mark this. B and C both have 2 in common, 3 in common, and 6 in common. So we know that B intersects C, which we could write under it, is 2, 3, 6. Now let's write out A. We know A, based upon what we have here, is 1, 2, 3, 4, 5. I didn't give myself enough space. Okay, class, I rewrote this just so that I would have enough space. So A is 1, 2, 3, 4, 5. Union B intersects C, which we determined was 2, 3, and 6. Now we will union these together, and remember, we only write one time what they have in common. So we will combine these. We will have 1, 2, 3, 4, 5, 6. And that is our final answer. Now we come here to B. Now B, we have A union B, in parentheses, intersect A union C. So now this is what we would need to do.